It may be nice to think about adding with the dots and boxes, especially when we're working with bases that we're not familiar with, but it's not really efficient. And we certainly don't want students that we might teach in the elementary classroom just using dots and boxes to add all their numbers together. It's going to get quite tedious. So we do want students to learn, the standard algorithm, the normal way we would add numbers up just by stacking them on top of each other. Let's take a look at a review question from base 10. And base 10, of course, is the base that we all grew up speaking. All right, so we all grew up understanding this. So it should look very familiar. If I were to add a number like 1,247 plus 973, I would work in the place values from the right to the left, always regrouping with a group of 10. And that made sense to us because that's how we were taught in school. Starting in the ones place, we have 7 plus 3 is 10. Now we don't write a 10 there. Rather, we say, okay, when I get to a group of 10, I'll move a 1 to the next place, which is a regrouping of 10. So I'll write a 0 at the bottom and carry a 1. Okay, in other words, I had a group of 10. Now I add in the tens place, I have 1 plus 4 plus 7, which is 12. No, I don't write a 12 down there. I think, okay, 12, that's really 10 and 2, right? So I carry a 1, that's really carrying a 10, and I leave 2 there. So 1 and 4 and 7 is 12. I'll write down the 2 and carry the 1, and I repeat the process. 1 plus 2 plus 9 is 12. So that's 2 carrying a group of 10, which we write as a 1 in the next place value. 1 plus 1 being 2, my final answer, 2,220. Well, we can apply that in another base. Let's try something in base 3. Remember, in base 3, we only have the digits 0, 1, and 2. So what I hope you find out here is that when you try to do the standard algorithm in a different base other than 10, you'll find out that if you can't count in that base, it makes it really, really hard to do. And so that should trigger something here that if we're going to be an educator and we're going to teach kids to add in base 10, unless they're really, really good at counting, this is really a worthless exercise. It's trying to teach them something where there's no foundation. And you can read any of the research to see that simply won't work. Many times math concepts have been taught, probably to you or to me or to many kids, as, okay, this is what we're doing today, but not tying it to something you already knew. It's a complete disaster. And it's no surprise that many times people are confused. So unless you can count proficiently up and down in any base, so like elementary school, of course, base 10, there's no chance that you're going to understand the standard algorithm for addition. You might be able to walk through it, but you simply won't get it. So let's take a look first at the count in base 3. And what I mean by the count is counting starting at 1. So the count is 1, 2, and we did this on a previous homework exercise. The next number is not 3 in base 3, right? Because remember, we only have the digits 0, 1, and 2. So we would regroup and say 1, 0, then 1, 1, then 1, 2, and then 2, 0, and 2, 1, and so on. So it turns out if you can just learn to count that far, that's plenty far to be able to add successfully in base 3. Let me show you an example. So let's take two numbers in base 3. We're never going to move those over to base 10. We're just going to leave them there and add them together using the standard algorithm. So what if I had something like 2, 0, 1, 1, 2 in base 3? Of course, if you've been working through the last few modules, you might think, I wonder what that is in base 10. And that might be interesting, but that's not what we're trying to figure out here. Let's say I added that to 1, 2. You can hear my phone going off, but I'm not redoing this. 1, 2, 2, base 3, and wonder what happens. Okay, well, we start in the ones place just like we did before. Now, I could always go back to this dots and boxes as a crutch. Well, I hate to call it a crutch because you're still learning it. And it's okay if you need to go back to what we already did in this module so far, but I'm going to avoid that on this video, but just know that that could be done. So starting in the ones place, you have 2 plus 2. Now, 2 plus 2 is 4, right? Well, not in base 3 because there is no 4. So we got to remember that. So one way to do this is to use the idea that you're counting on, and we kind of talked about this a little bit already. So if you start with the first number 2, and you can start on the top or the bottom number, and then you add 2 more, that's considered to be counting on. So I start with 2, and then I count 2 more. I add 2 more in my head. Well, the next number after 2 is 1, 0, 1, 1. I can show you that on the list above, right? Starting at 2, you can see me highlighting it there. Plus 1 plus 2 lands me at 1, 1. Okay, so that's a little bit new. So 2 plus 2 is actually, well, 1, 1. So do I write 1, 1? No, that's 2 digits. So I keep one digit, 1, but then I carry the 1. It almost will remind you of in base 10 when you add two numbers and got 11 and you carried a 1. Okay, so moving to the next place value, we have 1 plus 1 plus 2. We're looking at right there. Well, what is that? I might start with the largest number when I'm thinking about that. The largest number is 2. Then I'm going to add one more, and I'm going to add one more. So if I can count, it's still starting at 2, counting one more and one more also is 1, 1. So that's kind of an interesting thing. You'll get the same number in different ways. So that's 1, carry the 1. Then now in this place, I have 1 plus 1 plus, oops, kind of crossed that out. I was wanting to highlight it. We have 1 plus 1 plus 1. And so if you look at the counting list above, that's just the third digit, right? So it's actually 1, 0. So I'll put a 0, carry the 1. Then we have 1, 0, 2, 1 plus 0 plus 2. That's also 1, 0. So 0, carry the 1. And then I have 1 plus 2 plus 1, which is this many, fourth, right? The fourth counting number, which is 1, 1. So I'll just write down 1, 1 lastly. And that's my final answer. So it can be done with a standard algorithm. Let's take a look at this same process, but in a couple other bases so that you have a couple other references as well. Let's take a look at base 5. All right, base 5. I should write the word base here so you know what I'm talking about. So let's say I have something like 4, 3, 2, base 5. I'm going to add that to the number 4, 0, 4, base 5. Well, if you can start to do the counting in your head, it may be better. If you start in the ones place, 2 plus 4 will be the same, of course, as 4 plus 2. So if I want to count on, I do 4 in my head and I do 2 more. So 4, the next number is 1, 0, 1, 1. Of course, you have to be comfortable with the count. Illustrating the point I'm trying to make on this video is if a student can't count in elementary school, you might as well forget teaching them how to add, especially with a standard algorithm. They have to know how to add. In particular, they have to know how to add on. It's going to be very helpful. Okay, so the count in base 5 is different than the count in base 3. It's 1, 2, 3, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. That's plenty far. We won't need to go any further than that. So if you think about starting at 4 and add 2, if you land at 1, 1, and I was doing that, illustrating that in my head earlier. So you can do this as fast as you want. It's 1, carry the 1, and then 1 plus 3 plus 0 is actually just good old-fashioned 4, right? No regrouping there. And lastly, 4 plus 4. Oh, I know it's tempting to write 8, but we'll get it wrong. There is no 8 in base 5. So if we don't know it, we might check the count off to the right, or we can think about it in our head. 4 plus 4 more, counting with our fingers, it would look like this: 4, 1, 0, 1, 1, 1, 2, 1, 3. And so those two add up to 1, 3. I'll write that down. My final answer is 1, 3, 4, 1, base 5. Now this works in any base. It certainly works in base 10. It could work also in a base that's larger than 10. Let's use an example in base 12. Now in base 12, I just went to, typo there. Not really a typo, it's a righto. I just coined a new phrase, a righto. So remember in base 12, there's 12 digits and you have to add some extra ones. So we might want to refresh our memory on this a little bit. We have the digits 0 through 11. Now remember that we have 9 and A is 10 and B is 11. So it's the digits 0 through B. Okay, it's a little crazy. And then the count in base 12, which I don't think we've done much on that, but it would sound something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. And then remember 10, they have an A, 11, they have a B. And then when we get to 12, in base 12, we regroup and rewrite 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on. I'm going to just stop it there, but hopefully you're getting the general idea of what's going on. Let's take a look at a problem adding in base 12, and I'll purposefully try to put a little challenge here. So let's say we add 7A, 8 in base 12 to the number 5, 8, 6, base 12. Okay, what would we get? Starting in the ones place, 8 plus 6. It's very tempting to think 14. That's only true. The facts that you already know are only true in base 10. So 8 plus 6, I would start on my count at 8 and then add 6 more to that. Now, since I've written the list down, we can find it, right? 1, 2, 3, 4, 5, 6 will land you at 1, 2. Now, if you don't want to write the list and you can count successfully out loud, it might look something like this: 8, 9, A, B, 1, 0, 1, 1, 1, 2. Landed at the same place, but it is a little tricky without it written down. Illustrating again, it's very important to know how to count. All right, so it's 1, 2. I'm going to put a 2, carry the 1. Okay, I needed to undo my highlighting, so let me just write that again. So we have 2, carry the 1. Now we have 1 plus a, which is actually, remember, like a value of 10, plus 8. I would always start with the largest number. Start with a right here, and then I want to add 1 and 8 to that, right? I'll start with 1. There's my plus 1 right there, okay? Now I'm going to add 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm actually 2 numbers more, which would be 1, 7. I had to go and figure out what that was. So that's 1, 7, 7, carry the 1. Lastly, I have 1 and 7, 5. Now I'm going to illustrate a different technique here. It's going to be a little crazy. You might think about it later. You don't have to do it this way. You can always do it the way I've showed you, but just one last technique that I like to use is I know that I'm so much better in base 10. I sometimes rely on that. So I might see 1, 7, 5. That's what, 13 in base 10. I know that that's not the case here, but what will be true, what is nice, is if I know it's 13 in base 10, it's going to be the 13th number, whatever that is, the 13th number in base 12. So then I can just start from the left and count the 13th number. Like there's the first number, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th number. So the 13th number is 1, 1. And go, my answer is 1, 1. So my final answer is 1, 1, 7, 2, base 12. A lot to reflect on here in this.